In this video, we're going to talk about graphing linear inequalities in two variables. Consider the linear inequality 6x minus 2y is less than or equal to 8. Now, I claim that the ordered pair 2, 5 is a solution. Now, what do we mean to say that it's a solution? Well, it means that if you plug in 2 for x and 5 for y, you get a true statement. Notice what you get would be 12 minus 10 is less than or equal to 8, and of course that's a true statement. 2 is less than or equal to 8. Now, are there other solutions? Well, of course there are. For example, negative 1 comma 7, is that a solution? Well, notice you would get negative 6 minus 14, which would be negative 20. Is that less than or equal to 8? Yes. Okay, now what about the ordered pair 4 comma 1? If you plug that in, we would get 24 minus 2, which is 22. Is that less than or equal to 8? No, so that would not be a solution. Okay, now the graph of an inequality in two variables, x and y, consists of all points in the plane whose coordinates satisfy the inequality. In other words, whose coordinates, when you plug them in, make the inequality true. So let's look at an example. What does the graph of this inequality look like? 6x minus 2y is less than or equal to 8. Well, what we want to do is get y all by itself on one side of the equation. So the first thing we're going to do is subtract 6x from both sides. And notice the left-hand side would just be minus 2y. Then is less than or equal to, you could either write it as 8 minus 6x or minus 6x plus 8. Okay, and then we want to divide by negative 2 because we want to get y by itself. It's being multiplied by negative 2, so let's divide by it to get rid of it. But remember, when you divide by a negative number, you have to flip the inequality. Okay, on the right side, we can split this apart into negative 6x over negative 2, which is just 3x, plus 8 over negative 2, which is just negative 4. Now, how do we graph y is greater than or equal to 3x minus 4? Well, we plot the equation y equals 3x minus 4. Now, notice to graph this is going to be the same thing as graphing our original inequality. So how do we do this? Well, again, let's suppose it's y equals 3x minus 4. Notice the y-intercept would be 4, and the slope is 3, meaning that if you move to the right one, you'll go up 3. If you move to the right one more, you'll go up 3 again. And move to the right one more, you go up 3 again. Okay, so this line is the graph of y equals 3x minus 4. Now, we want to graph y is greater than 3x minus 4, so what we end up doing is shading above the line. You could sort of think of it as to the left of the line, but another way to think of it is we're shading above the line. All these ordered pairs that are above the line are going to make the inequality true. Now, notice the ordered pairs that we found, 2, 5. Okay, that's right in here. Okay, 2, 5 is 1, 2, 3, 4, 5 is right here. Notice that is in a part that we shaded in. Also, minus 1, 7, that's over here. Okay, if you plotted that point, it would be here. The one that we found that was not a solution was 4, 1, and notice that that is not shaded in. 4, 1 over here. So it turns out this is what the graph looks like. Now, we have a solid line here. The points on the line itself are solutions of this because we have the or equal to. Okay, if we did not have the or equal to, we would make a dotted line here, a dashed line. Okay, and we end up shading above the line because we have the y greater than. We would shade below the line over here if it were less than. Okay, let's do another quick example. Graph x plus 4y is less than 4. Well, again, we want to get y all by itself, so we're going to subtract x from both sides. The left side is just 4y. Then we have is less than either 4 minus x or negative x plus 4. It's the same thing. Then divide both sides by 4 to get y all by itself. We have y is less than, well, negative x over 4, one way to think about that is just negative 1/4 x. And then plus 4 over 4 would be plus 1. Okay, so we have y is less than negative 1/4 x plus 1. Now, if we graphed y equals negative 1/4 x plus 1, that would have a y-intercept of 1 and a slope of negative 1/4. That means if I ran to the right 4, I would go down 1. Okay, so you can draw in this line. Now, I'm going to draw it in as a dashed line. Okay, and the reason is because we don't have the or equal to here. And we're going to shade below this line. Okay. All the points that are underneath this line All the ordered pairs underneath this line are going to make this true. For example, the ordered pair 0, 0. Will that make this true? Yeah, if you plug in 0 for x and 0 for y, you would get 0 is less than 1. Notice that is a true statement. Okay, also you could plug in 0 and 0 in the original inequality. You'd see the same thing. Okay, so in any point that's above this, for example, 0, 4 would make it not true. Okay, if x is 0 and y is 4, notice, is 4 less than 1? No. Okay, so this is the graph, and notice the points on the line itself will not be solutions because we don't have the or equal to. Okay, now so here's kind of a summary statement of what we just looked at. If you have an inequality that's y is greater than or equal to mx plus b, you're going to be shading on or above the line y equals mx plus b. That's what the solution consists of. And when we say on, we mean we're going to make a straight line that's not dotted, okay, a solid line. When we say y is strictly greater than mx plus b, we'll just be shading above the line. Those points above the line but not on the line are solutions, so we'll make a dashed line. Okay, and a similar type thing for the less thans, only we'll be shading below the line, y equals mx plus b. Okay, let's do a couple of kind of special cases here. What if it's just y is less than or equal to some number? So it's kind of like y is less than or equal to 0x plus 3. Okay, well, if we just graphed y equals 3, notice y equals 3 is a horizontal line. Okay, y equals 3. And by the way, it might seem a little bit weird that we're graphing this in the Cartesian coordinate system rather than on a number line. You could graph this on a number line, but we're thinking about ordered pairs. What are all the ordered pairs x comma y that make this true? Well, if we get y is less than 3, we're going to be shading in these. For example, this ordered pair 2 comma 1. Does that make the inequality true? If we plug in 2 for x and 1 for y, will this be true? Yeah, there's no place to even plug in the 2, but when you plug in 1 for y, it's true. In fact, any point where the y coordinate is less than 3, okay, that's all these points down here, will make it true. So this is what the graph looks like. Okay, and if you were to graph x is greater than or equal to -2, now notice x equals -2 would be a vertical line here at -2. Okay, and I'm going to draw this as a solid line here. And we're shading in x is greater than -2. We'll end up shading to the right of this line. Basically, any ordered pair, okay, like 5 comma 2, this is an ordered pair that would make this inequality true. If we plugged in 5 for x and 2 for y, well, there's no place to even plug in the 2. But if we plug in 5 for x, we get a true statement. Okay, any point whose x coordinate is greater than -2 will make this true, and those are all these points to the right of that line.